This first chapter in physics is just a review of basic mathematical concepts from algebra and from chemistry that you used last year. And we'll be using these throughout the year. The first thing I want to look at here is what is physics? In looking at the definition, physics is a branch of science that involves the study of the physical world, energy, matter, and how they are related. And you may look at that definition and think, man, that sounds a lot like chemistry. In a way, it is. Usually, physics is considered more of the motion of things or how things will behave as a whole. However, it does get into the quantum scale or the atomic scale. So there is eventually a physics at the small scale. So they're very closely related. Objective 2, we're going to review the metric system, and it's called the SI system, the International System of Units, and it has 7 fundamental units that you need to know. And then from there, from these fundamental units, we have derived units, and that's just combinations of them, and really that's all there is. So you may think, why in the world would we use this metric system? Well, we used it last year in chemistry, and any lab in the United States would use the metric system, and anywhere around the world in their everyday lives, they use the metric system. Even England, who came up with the English system that we use today, uses the metric system. So what you have to know are the SI units over here. Length is the meter, which is abbreviated M. Mass is kilogram, kg. And the reason they use kilogram instead of gram is because a gram is a paperclip. So if you want to think of everyday objects in paperclips, you would probably have a pretty high number. If you want to think of your weight in paperclips, it's going to be a high number. So that's why they use kilogram as the standard. Time will measure in seconds, which is S. Temperature is Kelvin, K. Amount of substance is mole, M. And then, actually that should be MOL. And then electric current is ampere, which we also say amps, and it's abbreviated with a capital A. And luminous intensity, so how strong light is candela, and that's CD. So again, we get more units from these by using combinations, so like meters per second. And we'll use that one probably the most, but there's a few of them that you can come up with. Meters squared would be another one, and all other units come from there. So the metric system has these prefixes that we use. They have larger and smaller units for each type of measurement, and they can be created by using these prefixes. So we'll use those to transfer from one to the other. And it's quite a bit easier than our English system, trying to think about how many ounces there are in a pound and that kind of thing. Like all those little conversions, they're hard to remember. In fact, we don't even know our own system. If you know how many pecks are in a barrel, you probably don't even know what a peck is, besides when you get apples at the fall time of the year here. So it's actually pretty easy. So we're going to go over how to do that. It just changes by powers of 10, so that's what makes it easier, is that you only have to move the decimal. You don't have to think about, okay, what's divided by 16? What is that again? So that's what makes these a little bit easier. Okay, so looking at the prefixes, we have mega, that has an abbreviation of a capital M. Move the screen back over here. And then we got, that means a million, or 10 to the 6th power. Kilo is K, and that's 1,000, or 10 to the 3rd. Hecto is H, and that's 100, or 10 squared. Deca is DA, and that's 10, or 10 to the 1st. And then we have the base right in the middle. So you got meter, liter, seconds, grams. There's others too, but those are the main ones. And then getting into smaller units, we have deci, which is D, and that's a tenth, or 10 to the negative 1 power. Centi is C, it's 100th, or 10 to the negative 2. Then milli is an M, it's 1,000th, 10 to the negative 3rd. Then we jump to micro, which is mu. It's kind of funny looking U with a longer front. And we have 1,000,000th, and it's 10 to the negative 6. So looking at that, you see I have these thicker lines. Here you can see the power goes down by 1 each time. Going this way, they go up by 1 each time. Also, there's a jump of 3 around those two lines. So that's why I have the thicker line, because I'm not having you remember all the ones in between kilo and mega. You just have to know when you jump up there, you're jumping 3 spots. That's the thing you got to remember. Okay? So let's go ahead and try this. We got kilograms for our first example. So we start at K, kilo, and you have 0.005. So we got to go to deca. Alright, so we're going to go from kilo to deca. So you start at kilo and you go to deca. So let's see how many spots that is. Yeah, kilo is 1, 2. So there's 2 jumps. 1, 2 from kilo to deca. So you go 2 to the right. So you move your decimal 2 to the right. And so that puts it right there. So then you have 0.5 decagrams. So now you're at decagrams and you got to go to grams. Grams is the base. So you jump 1 to the right, move it 1 to the right, that makes it 5. Centi, you're at grams, so centi is 2 to the right. So, my decimal point's right here. I move it to the right. I don't have any numbers to go around, so you have 2 empty jumps, and your empty jumps, remember, you put 0, so that's 500. At centi, then you go to milli, it's 1 jump to the right, so then another jump is an empty jump, so you add a 0. Then micro, milli to micro, that's 1 jump. Why did I go 3? Oh yeah, that's right, when I jump over that line, I'm really jumping 3 spaces, so you gotta remember I'm jumping over 3 to the right, so I add in 3 more spots, 3 more zeros. Let's try one more example. We have millimeters, mm is millimeters. We got to go to centi. So milli to centi is 1 to the left. Your decimal right now is at the end when it's not there. 1 to the left would make that number 7. Centi to just an m is meter. Centi to meter, going 2 to the left. Decimal's right here. 2 to the left. We have an empty jump, so we add a 0 there. Comes 0.07. And then you're at meters, you're going to go to hecto. 2 more to the left, and then that means you have to add 2 more zeros, so you got the 0 and 1 more, so it's 0.00. And then you go from hecto to mega. Well, 1, and remember this jump is 3, so you got 1 plus 3 more, which is 4. So you go 4 to the left, so that means you're going to have to add 4 more zeros up there, so it's point and a total of 6 zeros and then a 7 megameters. So that's how you convert one to the other. A lot easier than thinking of how many pounds in an ounce, how many fluid ounces are there, in a pound, like all those things. So, in a cup and going up from there. So it's a little bit easier with the metric system. We'll use scientific notation quite a bit throughout the year. We have a chapter on circular motion, and that deals a lot with planetary motion. So we'll have huge numbers. Instead of writing out all the zeros, we're going to use scientific notation. So this is a quick review on scientific notation. So it's a way to write big and small numbers more easily without having all the zeros on there. So this is how we do it. You move the decimal point until the value of the number is greater than or equal to 1 and less than 10. So basically you want a number to start off with between 1 and 10. Determine the direction and the number of places to return the decimal back to its original position. So think of how you move it back to where it came from. And this sign, this will be the sign of the number of the power. So if you move the decimal back to the left, the power is negative. If you move it to the right, the power is positive. Alright, so make sure you get those in there. Let's go ahead and give this a try. So we got this huge number, 3,210,000. Alright, right now your decimal's at the end. You have to move it so it's a number between 1 and 10. So I'm going to move this decimal right there between the 3 and 2. 3.21. Is that a number between 1 and 10? Yeah, it is. So I'm going to move it right there. And then I ask myself, how do I move it back to where it came from? Well, I have it between the 3 and the 2 right now. So how do I move it back to where I came from? Well, that would be 1, 2, 3, 4, 5, 6 places to the right. So that would be a positive 6. And if you just think about it, does it make sense that you're multiplying by 10 6 times? Yeah, because this is a huge number, right? Let's try the next one. Decimal's here, so I got to move it between the 5 and the 7 to make it a number between 1 and 10. So 5.76 is between 1 and 10. So my decimal's right here. How do I move it back to where it came from? Well, I got to go 3 places to the right. So again, that's a positive 3. 10 to the positive third power. Then for C, I'd move the decimal right there between the 1 and the 2, because 1.28 is between 1 and 10. And then I ask myself, how do I move it back to where it came from? Well, I have to go to the left. How many places? 4 places. Going to the left, remember, is negative, so that would be a negative 4. And if it makes sense to you to think about it this way, really the negative means that goes on the bottom. 10 goes on the bottom, so you're dividing by 10. So 1.28 divided by 10 4 times would make a smaller number, and it does. Looking at the next one, the decimal would go between the 8 and the 9. 8.92 is between 1 and 10. To move it back to where it came from, you have to go 2 to the left, -2. And then this is going the other way. So we have a +6. That means we got to move the decimal to the right 6 places, making it 4,100,000. So you can see that decimal was moved 6 places. 5.09, moving it over 3 places to the right because it's positive, is 5,090. -6 means move the decimal to the left 6 places. So the 1 counts as 1 place, so I have to add 5 zeros in front of that to make it the number. And then the last one, -8, means I have to move it to the left 8 places. Well, the 4 counts as 1. That means I have 7 empty jumps, so I have to put 7 zeros in front of it. So 0.70491. I wanted to give you two little shortcuts on multiplying and dividing when you have exponents to make it go a little faster for you. Remember, you can always use your calculator on this, and I'll show you a shortcut on your calculator also to make it go faster, especially when we start using these a little more. But looking at this example, multiplying. If you're multiplying exponents or multiplying scientific notation numbers, you add the exponents. So you can see you have this number multiplied by this number. So when you have that and you have the same base of 10, you can take your exponents and add them. So you multiply your two front numbers first, just like you would. This is multiplying. So 4.1 times 5.09 gives you 20.86. Then you have these are also being multiplied. Well, if you're looking at this, then you add your exponents. So you got -6 plus 3. Well, -6 plus 3 gives you -3. So then we have this number, 20.86 times 10 to the -3, which would be correct. However, when you look at that, you got to make sure that you don't, this number in front is between 1 and 10, and it's not, it's 20. So to make this between 1 and 10, I'm going to have to move my decimal to the left. And so you ask yourself, how do I move it back to where it came from? Because I wanted to make it a number between 1 and 10, it's 2.086, which is the number between 1 and 10. How do I move it back to where it came from? Well, I'd have to go 1 to the right, and that's positive. So that means I have to add a positive 1 onto my exponent. So -3 plus 1 is -2. Dividing, going through an example here, we have the same two numbers, now they're being divided. So you take the front two numbers and you divide them. 4.1 divided by 5.09 is 0.81. Then you have the two bases, and it says when you are dividing them with a similar base, you subtract the exponents. So you take -6 minus 3. Well, -6 minus 3 is like adding the two together, so -6 plus a -3. So you get a -9, and you have, that won't work because that needs to be a number between 1 and 10. So you got to move the decimal between the 8 and the 1. You ask yourself, how do you move it back? Well, you have to go 1 to the left, and that's negative. So this should be 10 to the -10th. So sorry about that, I have the wrong number. Make sure you change that to a 10. It's 10 to the -10th because you have to go back to the left, and that's a negative. So -9 plus a -1 is a -10. Alright, so make sure you correct that. Let's go on to the last objective.